Next is Covestro and Aperio. With me is Rich Guhl from Covestro, Jonas Hellgren from Aperio. Throughout the day, we've talked about analytics and process improvement, monitoring our equipment. At the core of that is data, and one of the key weaknesses is data quality, and how do we make good decisions on bad data, and how do we identify bad data in the first place. So I'll let them introduce themselves and take it away. Thank you.
Ready?
Introduce ourselves first?
Yep.
Okay.
Okay, thanks, Steve. All right, let's see.
We're up.
Yep. All right, thanks very much for your time. So yes, like Steve said, today we're going to talk a little bit about data integrity or data quality and what the root causes of data quality issues are and what can be done to solve those. So I'm going to kick this off and then hand over to Rich from Covestro to talk a little bit about what Covestro is doing about that. So I'm Jonas, I'm with Aperio. We're a data integrity platform. So I'm sure I'm not causing any kind of controversy here if I'm saying that poor data is a really, really big problem for all of us. And the problem ranges from outages, there are like the direct result of bad decisions taken off of bad data, to digital initiatives that fail completely. Machine learning models don't converge. It's a bit of the garbage in, garbage out problem, right? We're hearing from people that as a result of that, data scientists spend 80% of their time cleaning data, fixing data problems instead of doing data analytics or data science. So, today we're going to talk about what Covestro is doing about that problem and what we are doing together to solve that problem at scale. So I'll hand it over to you, Rich, to take that.
All right. Thanks, Jonas. Yeah, like Jonas said, I'm Rich Guhl. I work for Covestro. I've been working for Covestro or Bayer my entire career now for 34 years. And I'm gonna do something I have never done before. I'm gonna break tradition. I'm gonna give a shout out to a previous presentation today. So I don't know how many of you were here when Jonathan Alexander gave his presentation about Albemarle's AI program, all right? So for those of you who didn't, I'll give you a brief synopsis, right? So he gave these little styrofoam balls out to the entire audience, and he said, hey, these are stress balls, right? And we gave them to everybody. And then he got a volunteer and brought her up here and gave her a basket and said, you're the engineer. And he told everybody in the audience, okay, your ball's a piece of data. You're the process. Throw your data at the engineer, right? So the poor engineer was up here with her basket, and she caught 3 of these balls. There must have been 150 of them, okay? And Jonathan's point was, see, that's how hard it is for an engineer to sift through all this data, right? There's all this data coming at them, and all they see is a couple. I had a little different take. What I saw was a bunch of really bad data. I mean, I know mine was, right? If she would have tried to catch mine, she would have had to jump off the stage, and she would have never got back here to catch all the good stuff. And that's kind of what we're going to talk about today, is at a conceptual level, you know, what we're trying to do with Aperio to handle bad data, right? And sensor health will also be a topic. So, you know, at Covestro, we've been busy, you know, building out a predictive maintenance analytics platform, like most of you have, right? But our journey into, you know, predicting asset failures started by focusing on redundant sensor pairs. So there's hundreds, probably thousands of them in our company, and since they're all part of a safety loop, or almost all of them are, they're high priority, right? So about 8 years ago, we built our own PI-ACE application to help us monitor and analyze all of these sensor pairs, right? You know, and I don't want you to think that we've been spending the last 8 years just looking at redundant sensors. I mean, we're doing multivariate anomaly detection with APA. We've built out a pretty extensive PI-AF architecture. We've done some pretty extensive deployments, you know, doing a lot of KPIs, first principle KPIs and monitoring and that kind of stuff. But when you spend enough time thinking about, you know, what is it going to take to get good at predicting asset failures, you realize you're going to have to somehow distinguish between bad assets and bad sensors, right? And I think that's a pretty tall order, actually. And on top of that, we want to do it at scale, right? I don't want to monitor a handful of redundant sensors. I want to monitor all of them. And if we're talking about all of our redundant sensors, why not monitor all of our sensors, right? We had the presenter previously was talking about a bad flow meter all the time, right? And how we wanted to automatically start a workflow. Well, that gets us at Covestro, and we're a medium-sized chemical company, right? That gets us to about just shy of 500,000 tags scattered throughout 3 regional PI systems that need to be monitored quasi-real-time or as close to real-time as possible. And you know, that's difficult. So, and ultimately what we'd like to do is embed, you know, a flag, a KPI, something, you know, from Aperio deep within our AF structure that tells us, you know, or to make sure that all of our tools that are on top of that, all the analytics actually use validated data. And if we get to that point, right, then I think that'll make us a lot better at predicting asset failures, because we're going to have some insight in between asset problems versus sensor problems. Now, ultimately, and this is a long ways off, but I'd like to use this information real time in the control room to help operations during abnormal situations. And I'm going to show you an example of where that would have been very helpful. But first I want to talk about our own PI ACE application, right? So, and some of the PI guys are laughing because, you know, I think AF was around when we built this, but we didn't have it, right? So we built this application in PI ACE. We called it Redundant Sensor Diagnostics. And at the time, about 8 years ago, this was a pretty cool piece of software. I mean, you know, it gave us you know, a couple metrics that were pretty simple that we could measure, like it could detect flat lines and it could detect offsets between 2 redundant sensor pairs. It also had something that I think even today is pretty high tech. We had a fouling indication detection. And that's important for us because we have fouling heavy processes. But compared to a modern tool, you know, like Aperio, there's a lot of disadvantages, right? I mean, first of all, there's only 3 metrics, and Aperio has much more than that. And also scalability was a big issue. I mean, all of these sensor pairs had to be manually deployed, and if we tried to get clever and do similar sensors, that cost even more work. But at the end of the day, what's really missing is there was no further insight into sensor health, right? Maybe we knew that one was fouling, but that was it. We had no other insights. And you know, the last bullet point there is, I think if you've ever spent time in the control room during an abnormal situation, you've gotten to the point where you're looking at redundant sensors or even a cluster of sensors around an asset, and it doesn't look right, and you're saying something's wrong here, and you have no idea which one to believe. And that's an awful feeling and a big problem that we need to solve. So I remember when I first started out, I was working with a very pessimistic production manager. I'm sure you've all met one. And you know, we were talking about a real important sensor that wasn't very reliable. And I, being fairly green, I said, why don't we just add another one? And he looked at me like I was crazy, and he said, I will never do that, because then I'll never know which one's lying to me. And you know, there's a lot of wrong that he said there, but it stuck with me throughout my career so far. So now I want to give you an example of where this kind of technology that we're trying to work with would have been really, really helpful, right? So what you're looking at is a pair of redundant level sensors, okay? And it's all qualitative. We took all the numbers off, but it still tells the same story, right? So what you're seeing is several weeks worth of data, okay? And you can tell on the left-hand side that they're right on top of each other. All the little blips are the same, you know what I mean? The offset's really small. Everything's working great. So when production noticed a problem is at the end of the graph, and that's blown up at the bottom right, okay? Now, keep in mind our control scheme at the time prioritized preventing overfilling of the vessel. So that means that we would use the highest level to control. Okay, so the orange line is the highest level, and it looks pretty steady, right? So everybody in operations is okay, even though that purple line, the other level sensor, started to go down pretty quickly. So they're like, I think we're good, we're cool, you know what I mean? And then finally they hear the pumps cavitating, caused a lot of damage, shut us down for a few days. We lost quite a bit of money. So we did our own post-mortem, and we knew what happened. But then we were talking to Aperio, and they said, hey, give us a chance to tell you what happened, right? When we think one of those sensors failed. So we gave them a data set, including these 2 sensors, plus all the sensors around that tank. And what they did was come back to us, and if you look at the graph in the bottom left, they said that the orange sensor broke correlation with all the other sensors right at the beginning of that shaded region. And that's actually what we didn't know exactly then, but we knew that the orange sensor, which was a level sensor, had a cracked diaphragm. And that was the problem. And so we said, okay, let's work together. So I'm going to show you just really quickly how we plan on measuring success here financially, right? And actually we did this, kind of reverse engineered this. Before we started down the predictive analytics stuff, we said, hey, we're having a tough time measuring or thinking about how much we're going to save. Let's just do a top-down approach. How big is our pie, right? What is it that costs us money? And we said, okay, it's unplanned outages, it's maintenance, labor and material, and PMs, right? So you can't just cut all your PMs, but it's part of what you need to optimize. And we said, if we can just take a piece of that, it's going to pay for everything we want to do, and surely we'll save a lot more than that. I'd like to say we'd save enough to actually see it, but maybe next year we can talk about that, all right? From a high level technically, how will we accomplish this? Well, when we started to put together our AF structure about 4 or 5 years ago, even before we had met Aperio, we knew we wanted to have some way built in to handle bad sensors and bad data, all right? So we built our AF architecture with 3 trees. So on the far right, we have our simulation tree. It's not really related as much to the other ones, but we're a big in-house simulation company. So we do a lot of steady state online simulations. We store that data in Pi, and we want to grade it compared to our other sensors right out in the plant for real time and get a feel for maybe if some sensors are bad or if our model's bad and how we need to optimize. All that data goes into the archive. From there, it goes over to what we call the PCT tree, right? Along with some soft sensors that we're calculating as well. And there, we always envisioned we would have some flag. We didn't know what. We didn't know how much processing we'd have to do before that. We'd have a flag that would tell us that a sensor's bad, and then somehow maybe we replace it with a soft sensor, a simulated value, or simply flag it as bad and remove it from the rest of the analytics stack, right? And that's where it goes from there. After the PCT tree, it goes to the asset tree, which I think is a normal part of an AF structure. We have our heat exchangers, our pumps, and everything, and all our analytics built on that. So that's our long-term vision on how we want to incorporate Aperio into what we're trying to do with sensor health. And Jonas will tell you how that's going to happen.
Okay, great. So let's see. So we're going to wrap this up then by sharing a little bit about the kinds of issues, the root cause and the impact, and then how it all works, and then we'll take some questions. So on one hand, so there's sort of 2 kinds of problems. One would be sort of sensor health issues per se. For example, the sensor drift issue that Rich talked about before, where you may have multiple sensors and one gives you the wrong value, but you don't know which one to trust. Then there are, and there's sort of lots of variations to that: sensor bias, sensor calibration, noise that could be caused by sensor connections and things like that. And so so that could lead to outages, of course, could lead to bad decisions based on bad data. And to fix that, of course, you want to go and fix the sensor. But how do you know the sensor is bad? And sometimes months go by before you find that out. Or, for example, if you rely on sensors to measure flow, you're going to run around and try to calibrate the sensors every 2 years because you can't do it any more frequent than that. But what if you could know ongoing, about that problem? And then you have other sort of like Pi data issues, like for example, a Pi interface goes down and all of a sudden you're not getting any data for weeks, and so you have large gaps in data. And so what happens then is when you get there to your system of record, which is your Pi server, and it's just not a system of record anymore, and you never knew that, right? Or your greenhouse gas emissions reports just don't have the data that you need, to be able to run them. And so there's obviously lots of different flavors of that as well. So these are just some examples, and then there's dozens and dozens of more. So those are the types of issues, that cause these data issues, that cause these bad business outcomes. And so how does that work? The way it works is that we have basically a connector into the Pi system that is able to read data on an ongoing basis, and then subject that data to a number of engines. And these engines are all machine learning based, because whereas if you only had a few tags, maybe you could do this by configuration. You can do your set points, for example, and use that for your outer range or something like that. But in the case of Covestro, you talk about 450,000 tags, or some cases millions of tags, then that no longer works, right? So it's all gonna have to be automatic and without the need for configuration. And then around that, there's a bunch of framework that allows you to organize this, aggregate this into higher level events, and then take action. And so then different things can happen. For example, we can enrich the tag in Pi with metadata that'll tell you, what's the quality of this tag? Can I use this tag? Can I trust this tag? Or you might want to be able to run histograms and reports by interface, for example, over time, and understand how the quality of data improves or declines over time. That's how it works, and that's how we do it at Covestro, and that's how we help make your Pi data better and more reliable. So I think that was it, and we finished early. So yeah, if there are any questions.
Thank you.